Welcome back. This is the third lesson recording for IM2, October 26, 2020. Now, we're going into right triangles. So far when we were studying congruence and similarity, we started with polygons, and then we narrowed it to triangles to develop shorthand tests to decide triangle congruence and similarity. Now we're going to narrow further to right triangles. And we are going to get started on the Desmos. The link will be available for you in Canvas. And you're completing all the cards. And I'm not going to go through these because the Desmos exercises are very straightforward. Okay, so some of the things that you should have taken away from it. The special side names are legs and hypotenuse. Okay, and right angle is the largest angle, because the other two angles must add to 90 degrees. That means the right angle is the largest angle, which also means the hypotenuse, which is always opposite the right angle, it is always going to be the longer side by the triangle side length inequality. So and we can also use Pythagorean theorem on right angle triangles. If you recall, Pythagorean theorem said leg 1 squared plus leg 2 squared is hypotenuse squared. Or you might have seen it as a squared plus b squared is c squared, where a and b represent the legs and c represented the hypotenuse. So in this case, so how do we solve this? Remember, the two sides next to, adjacent to, or next to the right angle is the leg, and this is another leg, and this, the side that is opposite, that's always a hypotenuse. Okay, so leg squared plus leg squared is going to be hypotenuse squared. That, putting it together, 8 squared plus 12 squared is going to be, hypotenuse is the x squared. Okay, what's 8 squared? That's 64. What's 112 squared is 144, is x squared. Okay, 64 plus 144, that's going to be 208 is x squared. Okay, so to figure out x, we don't want x squared, we want to figure out x, we need to take a square root of that, right? So we need to take a square root of both sides to get x is equal to 20 square root of 208. And what is 208? Can I simplify further? Okay, so x is square root of 208. Can I simplify further? Yes, I can. I know that 280 is divisible by 4, which is a perfect square. So that becomes 2 times, what about 52? Can I simplify that further? Well, yeah, I can still divide that by 4, another 4. So that becomes 4 times 13. Because 4 times 13 is 52. So that becomes 2 times root 13, or 4 root 13. And this is my exact answer. And if I was to use the calculator, I would use it as square root of 13 times 4. And I get about 14.42. And this is where I am going to ask you to find it in exact form. This is the exact answer. And this is approximate. And we use that curly equal sign so to say approximate. And 14.42. This is where you look at, if I say x is 14.42, does that make sense? Well, it has to be longer than 8 and 12, right? But what is the maximum it can be? It cannot be any more than 20, right? Including 20. So it is between, it's less than 20, but it's bigger than 12. So this sounds like it's about right. Okay? Let's do the next one. Now this time, what are we given? Okay, how do I know? This is going to be my leg. This is a leg. This is another leg. And this is hypotenuse. How do I know this? Because the side opposite the right angle is going to be hypotenuse. And the two sides that are right next to, surrounding the right angle, are the legs. So that means x squared plus 4 squared is 8 squared, because leg squared plus leg squared is hypotenuse squared. So that means x squared plus 4 squared is 16 is equal to 64. So I need to subtract 16 from both sides, and I get x squared is 64 take away 16, that's going to be 48. Okay, so then I take a square root of both sides, because I am not interested in x squared. I am actually interested in just x. So x, this square and square root, they cancel each other. You're left with x is equal to square root of 48. And now we want to see, can we simplify this further? Okay, square root of 48. I know that it is divisible by 4 times 12 is 48. And I know that 12 is further divisible by 4 times 3. So that means I have 2 times root 3, because square root of 4 is 2, square root of 4 is 2. So 2 times 2 is 4, root 3, like so. So the final answer is 4 root 3. And again, this is my exact answer. And if I was to find an approximate answer using the calculator, I would get 6.92, 6.93 to 2 decimal places. Okay, so now look at this number. Does this look right? Don't just write it down as, okay, that's my answer. Go back to the original question to see if it makes sense. If this was 6.93, okay, we expect the hypotenuse to be longest, okay, and so, and 6.93 is smaller than 8, okay, so that works out to be about right, okay. All right, so I want you to pause the video and then try to find the answers to this, and I want you to find the exact as well as calculator value as well, to see if your answer makes sense. Okay, here are my answers. Again, this is the hypotenuse because it's across from the right angle, so this is the hypotenuse side. So the equation becomes the leg squared, 10 squared plus 5 squared is equal to x squared. And so that's 100 plus 25 is equal to x squared. So that's 125 is equal to x squared. Take a square root of both sides and you get x is equal to square root of 125. And 125 simplifies to 25 multiplied by 5. So square root of 25 is 5. Multiplied by 5 becomes x is equal to 5 root 5, which is the exact solution for the x. And if I use the calculator, I get 11.18. And which makes sense because it is the longer, it's longer than 10 and 5. So 11.18 makes sense. Okay, what about this problem? Again, this time, the hypotenuse is the 7 side with the 7 as the measurement. So then the equation becomes x squared plus 4 squared is equal to 7 squared, because 7 is the hypotenuse. That becomes x squared plus 16 is equal to 49. Subtract 16 from both sides and you get x squared is 33. Now 33 is not divisible by 4, 9 or 16 or any other number. Okay, by the time beyond 25, it's 36 is too big, right? So you don't even have to go any farther than that. So I know that 33, it's not, there are no perfect square factors, so I leave it as it is. So x is equal to square root of 33 is the exact answer. And if I use the calculator, I get 5.74 as the approximate answer. Okay, so now we're going to move on to yet a different topic. It's called ratio within similar triangles. So up to now, what have you been doing when you're told that these two triangles are similar? Then we've been setting up the equation as 12 with 12 divided by 24 is equal to 5 divided by 10. We're matching up the corresponding sides of each of the triangles, right? But let's generalize this and call this the green side A, and then this bottom side of the first triangle B, and D and E accordingly. Okay, so that means we set the side length A over D, A over D, they correspond to each other. A over D is same as B over E. If B represents whatever the side length of this side compared to length of E. But from here, from this equation, if I multiply both sides by D over B, I'm allowed to do that because I'm multiplying the same thing to both sides of the equation. Then what actually happens is the D and D cancels out, and B and B cancels out, and you get A over B is equal to D over B. Now let's look at what A and B is. A over B is going to be same as D over E. So that looks a different version of A over D over B over E. Okay, so before we are matching up the corresponding sides from two different triangles, but now this time we are doing the ratio within one triangle to a ratio within another triangle that are similar. Okay, so, and if I was to use the previous numbers, so I know that 12 over 24 was same as half, and 5 over 10 is same as half, so that came out to be true. Well, if I did the same thing here, 12 over 5, is that going to be same as 24 over 10? Well, this does work out. 12 over 5 is 2.4, and 24 over 10 is also 2.4. So the ratios are exactly the same, as we've also derived the equation ourselves. So what this is telling us is a similarity proportion rule allows a different comparison. So what we are comparing, instead of corresponding side from the two different triangles, we are comparing the ratio between within a triangle to a ratio within another triangle that are similar. So this is where you're taking notes. If two triangles are similar, a proportion can be written comparing sides of the same triangle to their corresponding sides of the other triangle. So side B of triangle 1 over side A, side B of triangle 1, if this is triangle 1 over side B of triangle 1, is going to be same as side B of triangle 2 over side A of triangle 2. So this is what we have. Okay, so how can we use this? Well, we can use this the same one way. Okay, so if the first thing you do is you set up the equation. So it's going to be 11 over 4 is going to be same as x over 7. Before we used to set up as 11 over x is equal to 4 over 7. Okay, but now we're going to go within the triangle and within the triangle. And the reason we're doing this is as we go further into trigonometry, this is going to be helpful for sine, cosine, tangent ratios. Okay, so then from here you cross multiply and you get x to be 77 over 4 or 19.75. Okay, now this time you try this, and after you're done with this, and you're going to try this problem. Okay, and that's it for the day. Thank you for listening. And that was the final slide where you wrote down the table of content and submitted your notes for today.